Well, hey guys, welcome to Hilltop Machine Works. I am Tom. Come on in. Hey everybody, it's Tom here. We are back in the shop for another project. So, I watch another channel called Red Tool House. It is a family, Troy and Kelly and their kids. They live on a 100-acre farm up in the hills of West Virginia. And episode 109, Troy was trying to wind up his electric fence wire, because what he does is he raises pigs and he has them graze in various areas on the mountain range there, and once that area has been grazed too much, then he will move his pigs, and what he has to do is move the electric wire. And what he was doing is he was trying to reel it up with the drill on one end, and then he had a pole and he had some sort of, I don't know, looked like some sort of pipe T-fitting, and he was trying to roll the fence up, and it kind of worked for him. But being that I enjoy the channel, I'm a viewer of the channel, and we've corresponded a little bit with email and back and forth and whatnot, I figured I'd hook them up and we'd make them a real electric wire roller upper thing. So the plan is I've got a nice piece of 3/4 inch here. It's a pipe. We'll hack it off about 14 inches, and then what we're going to do is on one end we will make a little stub shaft. It'll go in here. We'll weld it up. It's going to have a washer on it. That way when he rolls it up, he'll keep the fence, you know, in between these 2 points. On this end, what we'll do is we'll mill it down 3 flats for the drill chuck to be able to grab onto and not rotate and slip. And then on this end, we are going to build a handle. And at the end of the handle, we're going to incorporate a bearing so it'll spin real freely. And then we're going to have a housing that'll house this bearing, and that way we'll take the housing and we can weld it to the handle, and that's the way it'll be attached. And of course there'll be a washer on the other end. So let me show you what I got. I kind of drew it out a little bit, got some dimensions, so hopefully I won't make any bozo mistakes. And I imagine once Troy gets this, he'll probably put a link in it to my channel. So if you are a Red Tool House viewer and you're just coming now to my channel to check this out, hey, I appreciate you. Hopefully you will enjoy this stuff. If you hadn't experienced welding, metal fab, and machining, then you know, hey, subscribe and leave some comments. Let me know that you come from Red Tool House. It'd be cool to see you know, other people that haven't been exposed to this kind of stuff. So anyways, without further ado, I think the order of operations is going to be, I'll go ahead and cut this down on the bandsaw, and then I'll round up some stock so we can make a couple of these stub shafts, and we'll do a little bit of lathe work. So let me move the camera around and come along. Just cutting the 14-incher. Alrighty, got you guys over here at the lathe. Got a piece of mystery metal chucked up in here. This is like 1 1/8 inch diameter. There's probably just going to be some, 1018 hot rolled or cold rolled steel. So the plan is we'll go ahead and make this stub shaft here. 831 is kind of an odd size for collets, so because this is what we're going to this end here, we're going to mill 3 flats on it. I need to hold it on this section here, so I need this to be a good number. So what we're going to do is we're just going to turn this down to 1 inch. I'm going to put it in an inch collet with this hexagonal collet holder, and that way when we go into the mill I can easily index 3 flats. So if we mill one side, we'll rotate it 60 degrees, mill another side, rotate it 60, rotate another, and then bam, we're there. So that's easy. So let's get this turned down to 1 inch, and then we'll get rolling here, I guess. If you hear that little background noise, it's a little warm today, so I got the fans running. First off, we're just going to face this thing so we got a nice flat surface to start reference off of. Just doing this by hand. We're running hot chip, 570 RPMs. We want 1 3/4 of an inch overall length. And I'm gonna have to pull it out a little more so I'll be able to face it. Cut it off there. Let me get just a tad bit more. Zero. Like I said, this isn't a precise measurement, it's just something I figured we'll just run with 1 3/4 of an inch. Alright, we'll zero there. And let's go take a skim cut and we'll figure out how much we need to take down. Dial in about 20 thou, clean it up, see if the chips will break. There you go, not bad, 1018. work with. Just gonna whittle her down to 1 inch. Let's see if I can get a mic on her. Might have to go to my 1 to 2 mic. I don't know if I'm close enough to 1 inch to get this mic on it, but we'll see. Nah. Alright, hang on. Let me get my 1 to 2 mic. Alright, let's see what we got here. Get my eyeballs on here. So we got 1 inch, 25, like 50, 65. We got 40. So let's take another 20 and we might be there. Alright, made hopefully the last pass. Let's see if we're there or not. There you go, 0.9995. I'll take it. Not bad for this lathe. So, next what we need to do is make a stub on that stub, if you remember. So this is going to be the 1 inch, which will eventually be turned down to 0.831, and this is going to be the 1/2 inch part that we need to cut the 3 flats on. So we need to come down about 3/4 of an inch in, and we'll turn this diameter down to 1/2 inch, 0.500. So let me and 0 you there, and we'll take you down to 750. And like I said, this isn't a critical dimension. I just figured 3/4 of an inch would be good. Enough to stick out for the drill. Alright, we're at 750. So let's chew her down some more. Alright, I'm going to continue to do this and I'll bring you back when I get to the last pass. Alright, getting really close, so I figure I'd grab a measurement here. I want to cool down a little bit also. And so we got about 50 thou to take off. Yep, 550 and 8/10. So let's take another 50 off and we should be at our final dimension here. See if we'll do it one pass. that shoulder there. We'll back it out so it'll have a nice shoulder. Alrighty, we should have hit it. Still large. 502. 2 thou over. That'll be alright though for what we're doing. Let me break a couple edges, and then what we're going to do is part this off. Come on, baby. Now we want overall length of 1 3/4 of an inch. Zeroer, and we'll go down 1 3/4 of an inch. Which is that right there. Lock the carriage, and we'll slow her down a little bit. Lube, and let's see how it should do. Biggest thing is keeping it lubed and keeping the chips out of there. And they're curling out pretty good. You can see that. My big hand's in the way. About ready to go right here. Just gonna grab my blade. Come on, baby. Give me some love. Alrighty. I'll grab it, but I know it's hot. Come here, baby. There you go. Alright. So we got one stub shaft. So collet's gonna hold her here, and we're gonna mill 3 flats on her. So let's take it over to the mill. We are set up at the mill. Got the 5C held down here. 3/4 inch end mill 4 flute. And I've got everything set up, so let's make a few passes here on camera. That's my phase converter For those that are new to the channel, this mill runs off 3-phase power, and that's the only way to make it because the power company won't bring 3-phase to my shop. Get a little bit of speed. Find 0. Have an idea about where it's at. Of course, that's going to be in the way. Let me get this knob out. Never fails. Let's try that. Just kissed it, alright? Go down 25. Another 25. That's all we need, one flat. Now let me get her out and rotate her, and we'll get the other 2 sides done. Got it rotated, 25 thou. First cut on the second side. For a total of 50. Alrighty, I'll knock the third one off camera and I'll bring you guys back when I get it done. Okie dokie, finished up the last pass. As you can see, I numbered it 3, 2, and 1, so that way I wouldn't do a bozo and mess up. But there she is, and let's get her out of the collet chuck here. There she is. Let's go get a drill and see how she looks. So, put her in the chuck, tighten her down, and we're in business. So let's take this back over to the lathe, and then we'll turn this down to the 831 diameter that we need, so this will slip inside the piece of pipe. Alright, we're back over here at the lathe. Just going to turn this down to that 831 diameter. You saw me already turn it down previously, so I'm not going to bore you with more turning. So I'm just going to go ahead and buzz this off to our final dimension, and I'll bring you back when I get there. Alright, we should be at our final dimension now. Just been chewing her down, brought you back. See how we did. 831 and 2/10. Alright, I'll take that. Let's see if let me break this edge right there, and then we'll see if she fits on there. There we go. There you go. Nice. Weld that baby on and we'll be good to go. Sweet. Alrighty, next operation we need to do, I think I'm going to do is go ahead and make the bearing housing. So I've got a piece of probably the 1018 here too. Some mystery metal that I got at the scrapyard. And it is 1 1/4 inch diameter. So if you remember from the drawing here, we are going to make this bearing housing here, which is this. I'm going to do an O drill bit, which is going to be a through hole, because this is 316 thou, and this part of the stub shaft will be going through it, and this is going to be 0.315 thou to have the press fit inside the bearing. So that'll give me an extra thou for this to stick through. But of course, you know, drill bits are going to wander, so the hole is going to be in it probably a little bit bigger anyways, by a few thousandths. So we're going to drill that, and then I'm going to drill in here a little bit, get me a hole to work with, and then we will slowly bore this out to the dimension of 0.865, because the bearing is going to press fit in there, and the depth of that hole is 0.280. So let me get set up and we'll start knocking this out. Alright, let's put a center drill hole in it first. Give the drill a fighting chance. Let's throw in the O drill bit. She gonna make it? Nope. Right there. There you go. And let me read out over here. Zero this out. Give a little bit of liquid love here. And let's put a hole in her. About halfway there. Looks like one flute's cutting better than the other on this drill. I have to resharpen it after this. Alright, we should be good. Alrighty, got you set up now with a 13/16 drill bit. Started to go give us a decent sized hole to start with. Unfortunately, we're not going, you know, very deep, only 280 thou. So by the time the drill bit starts to get in there and the flutes start to cut here, I'm gonna have to pull her out. So then we'll probably come in with a 3/4 inch end mill and give me a flat bottom, and then we'll finish her up to a final dimension using a boring bar. So I figured I'd give you a little rundown of the order of operation if you're new to machining. I slowed her down and zero that. Could have step drilled it, but I'm just trying to save some time here. We're almost there. Alrighty, should be it. Let me change this out and put the end mill in. End mill is in. Let's figure out our depth here. Alright, with 0 on the readout and on the tail squat. On the tail stock. Thickness of this is 30 thousandths. So we gotta go an additional 30, whatever my readout is. A little bit of liquid love doesn't hurt. Now let's flat bottom this thing. Now it's taking a full cut here. This is a center cutting end mill, so another 10 thou. Alright, we're there. Sweet. Alright, let's get this mess cleaned up. Boring bar is on, so what we're going to do now is we're going to go in and just clean up this hole a little bit so I can get a good measurement, because obviously the drill bit's not going to drill exactly perfect through the hole, and then we can figure out how much we got to take off to get to the final dimension. And I was hoping to use this boring bar, but I might not be able to. That looks like she's going to be rubbing, so we're going to have to go to the smaller one, and that means I've got to reset everything I just did. Alrighty, sometimes that's the way it goes. Alright, 0 there. You want to go 280. Alright, there's our depths. Now with 0. Come back and let's try this again. down at the bottom of the hole right there. Try to clean that bottom up a little bit if we can. Alrighty, I'm gonna keep whittling away at it and I'll bring you guys back. Got the hole cleaned up, so let's kind of see where we're at here. Using an inside micrometer. Gotta get the right feel. Let's see if she'll. And put some eyeballs on. See where 825, 830. Looks like we're at 832. Which means we got another 23 thou to bore out. Well, we are like oh so close. I got my gauge pins out when I really want to get accurate. So this is 865. This is what we're shooting for. And I mean, man, she almost wants to start. This is 864 gauge pin. These are minus pins, so they're going to read just less. And she goes in. So we are almost there. I don't know if I want to try to take a very, very light skim or just keep it as is. Okay, I took the most lightest skim pass I could, just a couple tenths, and now I can get the 865 in there. I don't know if you can hear that suction there when you pulls out. So perfect, because the bearing was 866 and 5/10, so the bearing is just a tad bit bigger. So I really wanted to make sure I got only about a thou or just a little more over a press fit. I don't want to, you know, crush the bearing at all or make it really tight and not want to spin freely. So we are good here. I'm going to take a skim cut just to clean the surface off, and then we're going to part this thing and cut her off, and then this piece will be done. So let me get her out of the chuck. She is cut to length, face cleaned up on this side, and broke the edges. So this is what we made. So the bearing will be pressed into here, and this will go, pretend my hand is the handle. It's going to go against the handle, and then we're going to weld this to the handle, and the stub shaft that's going to be coming out of the other side of the rod is going to be going through this hole. So now we need to build this other stub shaft. Well, I've been working on the second stub shaft, and I got her turned down. She should be where I want her. This is going to be the part that presses on to the bearing, and I got her. I wanted 315, so a couple tenths large should be just fine. Sweet. All right. So now what I got to do is turn this part down to 0.831, because this will be the part that slips into the other side of the long bar. Here is the other side of the stub shaft I just knocked out. So this will go into the bar, and this piece we just made earlier. So this is going to slide through, and it's going to have the bearing in there. The bearing is going to be a press fit into this, and this stub here is going to be a press fit into the bearing. And then of course the back of the handle is going to ride right there. So coming along nicely. Back over at the lathe, got the end washers, and all I'm doing now is just been chewing out the center here. I am almost there, because what I think I want to happen is have these slide on and then weld them. So just take a pass on camera for you guys. Blew off another 10 thou total. And we might be there on this one here. Let's see what we got. There you go. Nice. All right, I'll do the other one off camera. Well, we have all the parts machined. So let's kind of do a trial run here, show you what we're doing. So if you remember, this piece here is what we cut down and milled 3 flats on for the drill. So this is going to go in here. We're going to buzz a weld on her. Washer is going to go right here to basically retain the wire. And if you remember on this end, we made this little stub shaft, and we're going to be pressing this bearing on. But before we do that, we've got the housing that we made. So what's going to happen is we're going to, I think order operation is going to be, we'll press the bearing into the housing, and once we do that, then this will go through and this will get pressed onto the bearing housing and the bearing together. Then this will go in here, and we'll buzz a weld on there, and then we'll buzz a weld on the wire retainer. We'll need to drill a hole through here for the wire to be retained, so as soon as Troy starts it, you know, he can run a wire through there and then wrap it around, and then it'll continually wrap. So the only thing left here is to build the handle that's going to go on this side. And what I decided to build a handle this way, instead of maybe just doing a piece of stock sticking out straight, is this isn't really natural. You know, either your hands are usually together, either here or here, right? And he's going to be holding the drill this way, so that's why I figured I wanted the handle this way. That would be a little more of a natural feeling for him. So let me move the camera around, and we're going to have to do a little bit of geometry. I know you guys love math, right? Over here at the arbor press, let's get the bearing pressed into the bearing housing, and then that stub shaft through the bearing and bearing housing once we get this in. So hopefully she'll go in nice. Oh yeah, look at that, like a glove. You guys see that? Look at that. Came out perfect. Like it. Now let's get this baby on and see if we got a good enough hole. Yep. Alrighty, let me go get some parallels and we'll get set up. Let me get her started here, and I got some high-speed steel we'll use. Once I bottom out, there we go, we bottomed out. And just need to get it through the hole. There you go, nice. Alrighty, look at that. She's going to spin nice and smooth. Like it, like it. And it's just enough to locate through the handle. Perfect. Alright, let's go bend that handle up. Alright, so what we need to do is build that handle, which is basically going to be a circle we'll start off with. And remember your 11th grade geometry teacher telling you that, you know, after you learned all this stuff for her class that you wouldn't need to remember it again? Well, she was partially right, but we just need to remember good old pi, right? 3.1459. So we need to use this to find the circumference, because I'm thinking what I want is, this is going to be the handle, this is going to be where the bearing retainer comes in. Obviously this part won't be here. I was thinking about 5 to 5.5 inches originally, the diameter, but I'm thinking if he's using this in the wintertime with a glove, he might need a little bit extra room. So I think what we're going to do is do the diameter of this thing is going to be 6 inches. So the overall length, if we do that times 6, right? 3.1459 times 6. So the circumference is going to be 18.87 inches. And let's see here. So half of that divided by 2 is 9.43 inches. And so that would be here and here. The handle is going to be a little more, so let's add an inch here and add an inch here. So plus 2, 9, 10, 11. So basically about what's rounded off to 11.5 inches. So what we want to do is we'll take our stock and cut it to 11.5 inches, and we're going to put it in a bead roller, and we're going to form this arc right here. Math class is now over. Got my bead roller set up here, and what we're going to do is we're going to roll the handle. It's just an import. It does okay. I mean, I wish I could find a nice vintage American made one, but they hardly ever come up on Craigslist or eBay. If you do find one, then they usually end up being across the continent, and it's not worth the shipping or a couple days travel to go buy it. So let me turn the camera around a little bit so you can get a see a side shot and watch this thing bend up. So basically what we do is we just feed this back and forth, tighten it up a little bit. And we'll continue this, and hopefully we'll start getting an arc. Of course, it helps to feed it straight. Come on, baby. There you go. You see her now? Pretty good? Yeah, there you go. So, crank her in a little bit. Do it again. Crank her in a little bit. Do her again. Crank her in. Do it again. Alright, I'm going to keep at it, and then when I get real close, I'll bring you guys back. Well, I think we are there. I got a mark here and a mark here. And we are at just at 6 inches. So, sweet, we got us a handle. Alright, what you're looking at is the handle getting ready to get welded up. I just cut this piece off camera. Just kind of ground the edges a little bit on the belt sander and got her in, looking good. Got her raised up with a couple little pieces of thin parallels, and let's tack her and get her all welded up. So let me get some gear on. Hopefully it ain't gonna move on me too much. Alright, looks like a winner. Those are in. Yeah. Hope I'm in frame. I kind of moved a little bit, didn't I? Yeah, I figure so. Turn you around a little better. Alright, I'm going to finish her up here off camera for you, not bore you. Let's get one of these stubs welded in here while the handle dries. While it cools down. Alright, looks like it'll hold. Let me get this retainer welded on. Alright, that ain't going anywhere. Let's get the other one on. So now the bearing end is going to get welded up. Just the tricky part is make sure I just don't get any on the part that rotates, because that would be not good. think we got her. Sweet. Okay, got you set up over here at the mill. The only thing we'll have to do is we need to drill that hole. So I got her in my vise, 6 inches there. Hopefully there's not too much of a shadow. You can see that it's 3 inches. We're halfway there. Just running up on my square, and I made my line right there. So we're just gonna punch a hole, and after that, that'll be it. All we gotta do is weld her on, and this project will be done, besides cleaning up and put some paint on her. Just finished welding the handle onto the shaft. So there she is. Going to let her cool, knock off any weld berries, and then we'll wipe it down and throw some color on it. Well, no paint on her yet, but she just cooled down, so I figured we'd show her the the final product here. This is how it works. When this welded up right here, obviously the heat pulled it just a little bit, so it's not 100% true, so that's where the little bit of wobble is, if you notice, but still not bad. It still worked fine for them. So, cool. Let's get this thing cleaned up with some acetone and get some color on it. Well, it's the next day, and there you go. We have got one electric fence wire roller upper. So I hope you're happy with it, Troy. I painted it nice bright yellow, so when you lay it down in the woods, you can find it. Because I'm speaking from experience, when I know that you lay something down and it's dark in color, especially if I had painted this black, you had never found it, and you're like, where did I put that thing? So anyways, she spins real freely, should work well for you. It's just a tad bit off center there. I was worried about that when I was welding that stub shaft into the shaft. So that first tack pulled it just a smidgen, but you're only, spinning a few RPM, so it should work fine. So I hope you're happy with it, and if you're coming from Red Tool House, I appreciate you watching the video. If you like this stuff, comment down below, give me a thumbs up. All you new subscribers, I appreciate you coming out and checking the channel out. And to all you old subscribers that have been with me almost a year now, I appreciate you guys hanging out with me. It's nice to know that you guys are out there watching and commenting and giving me a thumbs up. It keeps me motivated to make the videos. So there'll be plenty more to come. So this project is a wrap. I'm going to get this in the mail, and you should have this in probably 4 or 5 days there, Troy, depending on how UPS delivers up there in West Virginia. So anyways, we'll see you guys later.